Hi guys, Mr. Biggers here, and today we are going to jump into our Unit 6 Lesson 1. This is a review on solving proportions and adding segments. So if you remember, to solve proportions, we have to do a method called cross multiplication. Some of you may know this as the butterfly method because it makes your problem look like a butterfly. So first off, what is a proportion? A proportion is when you have two fractions or two ratios that are equivalent to each other. So they're proportionate to each other, okay? To get rid of what I call ugly fractions, we're going to cross multiply, okay? So what that means is we are gonna circle these two letters and multiply them. So we have B times C, and then it's gonna be equal to A times D, okay? So when we cross multiply, it's gonna become BC is equal to AD, or whatever our numbers actually end up being. This method is nice. It makes it smooth for us because it gets rid of those ugly fractions that I don't like to see in problems. So we're gonna do this one together here. Cross multiply 7 times x is equal to 7x, okay? We're gonna cross multiply these two. 4 times 14. I'm gonna work that out really quick in my calculator. And that gives me 56. So to rewrite the problem here, we have 7x equals 56. No more fractions to deal with. And now we can solve this problem using our algebra skills. We're going to divide both sides by 7 to undo the multiplication. And when you divide 56 by 7, you get x is equal to 8. Okay? So that's using cross multiplication to solve proportions. I'm going to go through these examples. What I would recommend is that you pause the video and see if you can work it out before I do. But I'm going to go ahead and work these out really quick and explain them as I do so. So I'm going to cross multiply. That becomes 4x equals 2 times 10 is 20. So then we're going to divide both sides by 4. And then we have x is equal to 5. Since that is my final answer, I'm going to box it. Okay, now I'm going to go on to number 2. Once again, pause the video, see if you can work it out before I do it. Going to start here. 5 times 10 is 50. Then I'm going to start here. 2 times x plus 5. Now, some people are going to make a mistake here because they're just going to multiply the 2 times x, okay? But what you really have to do is you've got 2 times the quantity of x plus 5. So I'm going to write that out. It's 2 times the quantity, meaning parentheses, of x plus 5, okay? When you have a number multiplied to a quantity or outside of parentheses, we have to apply what's called the distributive property, and that's when you multiply, okay? So 2 times x gives you 2x, 2 times 5 gives you 10, and then the 50 will come down. We're going to continue working through this problem to solve it. We're going to subtract 10 from both sides. We're going to get 50 is equal to 2x. And then to continue solving, we're going to divide both sides by 2. 40 divided by 2 is 20. So our final answer is x is equal to 20. Okay, moving on to number 3. Once again, pause the video, see if you can work it out. I'm going to go on with this. I have x times 6 is 6x. You can start by multiplying any of the diagonals that you want. You could have started by doing this. It's up to you. X times 6 is 6x, and then I have 3 times the quantity of x plus 2. Once again, we have to treat it like it's in parentheses. So 3 times x plus 2, and then we're going to distribute that 3. It's going to become 3x plus 6 equals 6x. Now we want to solve this and isolate our variable, which means get the variable to only one side of the equation. So I'm going to subtract the 3x over to the left side of the equation. Remember, what you do to one side of an equation, you must also do to another side. So 6x minus 3x gets us to 3x, and then we still have our 6 that's left on the right side. We're going to quickly here divide by 3, and now x is by itself. X is equal to 2. That would be our answer for this question. Okay. And then number 4, I have x minus 3 times 6. When you multiply that out, you're going to get 6x minus 18. And then I'm also going to cross multiply here. 2 times x plus 5 is 2x plus 10. I'm going to go ahead and solve this out. Subtract my 2x over to this side to get my variables to the same side. Once I work out that math, it's going to be 4x minus 18 is equal to 10. Going to go ahead and add that 18 over to the other side. And you get 4x is equal to 28. And then once you have that, you go ahead and divide by 4. 28 divided by 4 gets you an answer of a nice smooth 7. Okay? So that is how we solve proportions. So how does this relate to triangles? Because we wanted to practice this skill because soon we're going to have what's called similar triangles. We're going to learn what that means in our next lesson. But as for right now, I want you to look here. I have 4 over 6 equals to y over 15. And this is from the diagram. So what they're saying is, they're saying that 4 is to 6, and I'm going to go ahead and do 2 colors here. So 4 is to 6 in the same way that y over here is to 15, okay? So these sides would be considered proportional. These shapes are similar, which means they have exactly the same shape. They are just different sizes. So it's kind of like a dilated version of itself. So we can use this understanding and this relationship of proportions to help us find a missing side value. Because we know that this side is not necessarily congruent to this side of the triangle. However, since the lengths are proportionate, we can set up a proportion and solve it. So 4 is to 6 in the same way that y is to 15. And so once we set that up as a ratio, as a proportion, we can solve it. So 6 times y is 6y. 4 times 15 is, I believe, 60, but we're going to verify that, yep. And then I'm going to quickly here solve, and now we know our side length for y is 15, or not 15, it is 10, okay? So I want you to see if you can figure out this one. Clearly, they gave us a proportion here to solve. On the next one, there isn't a proportion, so we need to set one up. I'm going to go ahead and work this up. So 4 is still the same to 6. It's still comparable to 6. So we're going to say 4 over 6. They want us to solve for y, or for x here. So we can see that x is also in our figure that's on the left. So the figure on the left is going to be on the bottom of the proportion because you want the 6 and the x, they're on the same figure. So you want to keep them into the denominator of the fraction. On the top of the fraction here is going to be the corresponding piece. So the corresponding piece to x is going to be 8. So we need to have 8 over x, okay? And so what we do here to solve is we cross multiply, and then we're going to figure out what is the value of x. So we're going to do 8 times 6 is 48. And then we're going to do 4 times x is 4x. And we're going to go ahead and divide that out and solve. This is going to be 12. X is equal to 12. Okay? So that's the front side, and that's how proportions can relate to triangles. In our next lesson, we're going to get further into that. On the back side here, I would like us to review the segment addition postulate. This is something that you should have already learned, but if not, we're going to try to catch you up to speed on this lesson. So let's fill in our notes here at the top. So if A, B, and C are collinear points and B is between A and C, then we know that we can take segment AB plus segment BC, and then that's equal to the whole length here of the segment AC, okay? So the part plus the part equals the whole. And we're going to see this sometimes in triangles, so it's important to practice this. So we want to use the diagram below for questions 1 and 2. Always label your givens. Always label givens. Make us a note. Okay, so we have PQ is equal to 9, we have QR is equal to 28, and they want us to find PR. Okay, so I'm going to label that on our shape here. So PQ is 9, QR, and mark that here. QR from here to here is 28, and then they want us to find the length of PR. Okay, so we don't know what that is. So easily to do that, we're going to add them together. It's going to be 9 plus 28. 9 plus 28 gives us 37. That's the total length of PR. Now, number 2 gives us a different set of numbers. So what I'm going to do here for number 2 is erase the markings that I have for the first one. If you don't want to erase yours, you can always redraw the line segment and then remark your pieces again. Okay, so in this one, they're telling us that QR is equal to 17. So there's 17. They're telling us that PR, the length is 21. So all the way P to R is 21. They want us to find PQ, this little piece here. So to find that green piece, what we're going to have to do is we're going to have to take the whole length, 21, the red piece, and we're going to have to subtract it here from the blue piece, or subtract by the blue piece. And then we're going to be left with the small little green piece. And once we do that, you're going to get 4. That would be the length of PQ. Okay? So we're going to use that segment addition postulate, the fact that 2 parts of a segment can add to the whole length to solve these problems. I want you to pause the video and see if you can work through these. I'm going to go ahead and work through these pretty quickly here. So any given information, make sure you mark it. So EG here is 71. So what I want to do is add EF plus FG. So EF here is 8x minus 17 plus FG is 5x minus 3. And that's equal to 71. Okay. So then we have 8x plus 5x is going to be 13x. I've also got negative 17 minus 3 is negative 20. And then still equal to 71 over here. We're going to add 20 really quick to get rid of that negative 20. Cross those out. You get 13x is equal to 91. Divide those quickly here. And then we're left with x is equal to 7. All right, that's the value of x. Always go back to your original question and make sure you've answered what they've asked. Okay? Number 4 here, if TV is equal to 14x minus 8, so here's TV, 14x minus 8, they want us to find TU, okay? So once again, we're going to use segment addition postulate. I'm going to have TU, which is 9x plus 2, plus UV, which is 5, and then that is equal to the whole length of the whole segment, which is 14x minus 8. We're going to combine our like terms to solve for x, and we're going to have to use that value of x to plug in to find the length of TU. So 2 plus 5 here is going to get us to 7, and this is still equal to 14x minus 8. Okay? I'm going to get my variables to the same side here, minus those. We get 7 is equal to 5x plus or minus 8. And then I'm going to add 8 to both sides. And this is going to be 15 equals 5x. Divide both of those sides by 5, and x is equal to 3 would be our answer. Now, you still have to take that and plug that into TU. So it's going to be 9 times 3 plus 2. Nine times 3 is 27, plus 2 is going to be 29. Okay? I'm going to leave 5 and 6 as an exercise for you because I'm out of time here on the notes. But if you are curious to know the answers, the answer for JL here is going to be equal to 62. X is equal to 12. Those are your answers. And for 6, if you work that out, you're just finding the value of x. Your answer would be 6. Thanks for watching.